Welcome to lesson 3. In this lesson, we are going to learn about the input-output library of Java, the Java I/O library, and the uses of that library to be able to read keyboard, to be able to read files on disk, to be able to write to files, and to be able to append files. After that, we are going to look at the Pojo. This is an interesting Java class. In the previous lesson, we used system out println or printline in the Hello World and in the other project to be able to display to the user messages. And that was output. Now we need to take this to the next level. We need to be able to get the user prompted to type something in the keyboard, and we need to be able to receive that. System in is used to get keyboard input. However, the code to do that is not trivial. And for that reason, I did research and I came up with something that's a lot simpler. You will make 5 changes to your class every time you want to get keyboard input. And those 5 changes will be the same. It will be consistent. So with time, it will become second nature. Ultimately, we want to have a reader object where we do a read line, and then that will bring us back the string of whatever the user typed on the keyboard when the user pressed enter. So where we had a print line, now we have a read line. In order to do this, we need to put above the declaration of the class the import Java I/O. This will give you access to the classes that Java provides in the I/O library. You need to change the declaration of your method to throw an exception where you are going to use input-output. Inside your main method, you will first add these 2 lines. And in fact, if you could create a rubber stamp and put these 2 lines on a rubber stamp, then every time you needed keyboard input, you would just stamp these 2 lines. Before you can get input from a user, you need to first prompt the user by using a println to display a message like this: what is your favorite meal? To get input from the keyboard, you need to declare a string variable and assign it like this. So my string variable is favorite meal, and I assign it to reader read line. So when I get the user to type something and press enter, that will be stored in my variable, in this case the favorite meal. This is the code we need to use to do that. If we look at the code, here we are importing the Java library, the I/O library. Here's the change we made to throw an exception. We did this on the main method. However, if you used any other method to do keyboard input, then in that method you would need to add this throws I/O exception. Later you'll learn that you can also throws exception. That also works. Now these are the 2 magic lines that I mentioned. If you created a rubber stamp and you put them in, it would be able to allow you to read the keyboard. So what this code is doing is the input stream reader is wrapping the system in. You can use the system in methods, but the code to do that is going to be a lot more complicated. So here the input stream reader together with the buffered reader, these 2 together do all the weightlifting for us. And this is how you would use it. You would say system out println or printline, and here you prompt the user, what is your favorite meal? And then, as we had in the previous slide, your string favorite meal equals reader read line. And when the user typed something and pressed enter, that would go into this variable and you could then display it in this line. Let's go and have a look at this in code. So here is the meal enquirer code. It's the same as the slide. I have made these files available if you don't have access to these files, or if you wish to create the code with me during the lesson, you are welcome to pause the video now and create a class meal enquirer. The file name will be mealenquirer.java. So you can pause the video now. I now need to run it and compile it, so let me open the terminal. I am now going to compile that code for the Meal Inquirer class. And the code compiled successfully, so let's run it. You see now it's asking me what is your favorite meal, but I am an Italiano, so I'm going to type cannelloni. Cannelloni, it's a pasta if you didn't know. And as I hit the enter button, immediately the program did what it was meant to do. It displayed. So that is how we read keyboard. Let's continue the lesson. We've read from the keyboard. Now let's read a file. In this case, we are going to use the file input stream class. This is also part of the Java IO library. So like we imported it in the previous class, we would need to do that in this class. And we have a requirement here. In order to open a file, we need to specify the file name. So in this line, we said file name is helloworld.txt. So here we are creating an instance variable in, and we are instantiating the file input stream class, passing it the file name as a parameter. And this is that constructor. So that will now give us an in object. And then here we can use the in object. This line of code here is inside a loop. This is a while loop. We'll learn about loops later in the next lesson. A loop is a piece of code that repeats. What this code is going to do is it's going to read one. Now if you see here, I've declared ch as an integer, an int. So this is going to read one number from the file, and it's going to read one number and that at a time. And in this line here, we're going to use a technique called typecasting. In movies, they typecast an actor to be the villain, and then they typecast another actor to be the hero. So here we are typecasting this variable ch, the number, to turn it into a character. And when we have a character, we can then add it to the string. So if the character was an uppercase letter A, in the file it would be saved as a 65. So we would get a 65 and we would be converting it to an uppercase letter A and adding that to the text, the string. And we would be continue adding one at a time until we reach a character that's a -1. Now -1 is the end of file character. And when we get the end of file character, then the code will stop reading. And in fact, it will not update the string with a -1. Now there is something you need to be aware of. Whenever you're reading files in this line here and in this line here, you have the possibility to throw an exception, or what you would call an error. We in Java call it an exception. And that will make your code crash. So to protect the code from crashing, we need to handle that. So I will be talking about this little rhyme. I am trying, I am catching, and finally I am closing. So here I am trying to run this code. If any error occurs in here, I will catch the exception here, and then I will handle the errors here. After that, I will finally close the file. Now it's very important that you don't miss the last step. I worked at a bank about 10 years ago, and a developer missed that last step. And there was 100,000 customers connected to that bank on one of their banking systems. And every time the file was read, Java will store the whole file in memory. So every time it reads a file, it stores it in memory. But because the files were not getting closed, slowly, this ate away at the memory until the server ran out of memory that it could use. At that point in time, the whole system crashed. So to prevent that, this is the reason why I sing the song. I'm trying to do something, I'm catching errors, and finally I'm closing the file. Do not forget that. So that was how we read files. Now we want to write a file. You'll notice that the code looks identical to the previous slide, except for 3 lines of code here. In this case, we use the file output stream. In the previous one, we used the file input stream. Now, I have the file name as helloworld.txt. So when I'm instantiating an object from the file output stream, I'm doing that in this line here. And this is what they call the constructor method of this class. And here I'm passing it the file name. So this will create an output object variable that I can now use. And then here I will say output.write, and I'm writing a message. Now just have a look here. We stored hello world in a string, but we are not writing the string here. What we are doing is we have an array of bytes, in other words, numbers. Remember, the letter A was a 65. So we are going to be using this line of code here, text get bytes. So the Java string has a method get bytes, which will convert the text into an array of numbers, bytes. Bytes are numbers, they are integers. And that's going to be stored in message. So when we write, that's why we write numbers to the file. And then when we do the close, at that point in time, the file was open so that you could manipulate it. Once you have finished manipulating and you say output.close, at that point in time, Java will write the -1 to the file and then close it. The -1 we said was the end of file character. There is one problem with using the file output stream, and that is every time I write to a file, it rewrites the file. Now that's fine for the first time, but the second and third time I want to be able to add additional text to it and not rewrite the file. So we need to use a different class to do that, and that is the print writer. The print writer works together with the file writer. As you can see in the last 3 slides, each slide had its own pair of powerlifting classes. So these are them, the file writer and the print writer. These 2 classes do the powerlifting. Now there is something specific here. When we say new file writer, you will notice we are passing it the file name, but we're also passing it true. True means that the file exists. So don't overwrite the file, append to the file. And that is how we set up the file writer class, and we instantiate it, and then we get the file writer object, which we pass to the print writer constructor, and we now get the print writer object. Now the print writer has a print lin or print line. Like system out print line, this has a print line as well. And print lines allow us to print text direct, so string. So you see here we never needed to convert the string to an array of bytes to write it. We could just pass it straight through. So that's how we use the file writer and the print writer combination. This is how we use it. And then the same applies. When you open the file to write, you do need to close the file. So file writer.close. So that variable that we declare here for the 3 slides that you saw, we always need to close it. And we do that in a finally. Now let's go to the code and look at this. I've now created a class called file utilities. It's a file utilities.java. If you want to work with me, pause the video now and copy the code up to line 39, and then pause the video now and copy up to line 70, and then pause the video now and copy up to line 102, and then pause the video now and copy the rest. Let's have a look at this code. So what I have done here is I have three methods: read file, write file, and append file. And if you look very carefully at these three methods, you'll see the code is the same. It's identical code. I'm a lazy programmer, so if I can create a stamp and reuse it, I'm doing that, and that's exactly what I'm doing here. But you will notice there's a few differences in my approach now. First of all, file input stream, I declared it as in equals null and not as in equals new. I did not instantiate it. I first made it a null object. The reason I'm doing this is that when I try to read the file, if something goes wrong and it crashes, I'm going to catch it in the catch blocks, in which case in will remain null. And finally, when I want to close the file, I'm going to test to see that in is not null. That's what this line here does. It tests that in is not null. And if in is not null, then I'm going to try to close the file. Notice that in this previous slide we just said in.close. But here I'm going to try to close the file, because in attempting to close a file, you may have quickly pulled the thumb drive out of the USB socket, and when I try to close the file now it's going to catch an exception. So that would make my code crash. But because I'm handling every kind of exception and every possible exception, this code is very hard. It will handle all the possible crashes without crashing. Something else you need to look at is I've got two catch blocks. I'm catching the file not found. So if we try to read a file, but you forgot to plug the thumb drive into the USB socket, then we're going to get this error caught in this catch block here. However, if you're running Linux or Mac, on the server we have folder permissions and file permissions. So the file may belong to the root user or to another user. You don't have this in Windows. So because the file may belong to the root user, you may not have permission to read the file. So when you try to open it, you are not going to get a file not found exception. You are going to get an I/O exception, because this is going to happen at the operating system level. So my code should be able to run on Windows, Linux, and Mac. So for that reason, I have these two catch blocks. Something else that I'm doing specifically in my file utilities class, I have an error message, and you'll see that the error message gets set with a different message for the one catch block and a different message for the other catch block, and the different message in the last catch block. So file not found, failed to read file, and failed to close file. So if any exception happened, the message will be stored. And I also have a Boolean variable where I say failed equals false. But now inside these catch blocks, I make failed equals true. And if it does catch in any of these catch blocks, then this line of code here now is going to be triggered. So if I say if failed, I'm going to be throwing an exception, and in the exception I'm going to be passing the error message. So whoever uses my code is going to get failed to close the file, failed to read the file, or file not found. And that's what they're going to get. So it's making my code very useful. This is a Java library that you should save and keep, because every time you want to work with files, if you use this code, you will never go wrong. This is probably the best code to use for writing files. They always recommend using streams. This is how I've done it. Now let's have a look at the happy situation. In the happy situation, I read the file. There was no error. I looped through the file like we did until I found the -1, and I saved that in the text string. And then finally at the end, I'd closed the file because there was no error here. And then at the end, I returned the text. So this is, with this method, you read a file and you get back a string with the content of the whole file. If the file is 2 gigabytes, you will get a string of 2 gigabytes. Now, exactly the same code I use to write file. Exactly the same code. The only difference is the 2 magic lines. So here you see I have a variable called out. And I've declared out equals null here. I'm doing the same as I did in the previous method. The same philosophy. Whatever I did there, I'm doing again here. The only difference is I'm now working with a different class. I'm working with the file output stream. And other than that, this code is identical. So when I'm writing a file, I'm not actually going to get anything back. So this method will be void. And then lastly, I want to append the file. So in this method, I'm using those 2 magic classes, the file writer and the print writer. And I'm declaring them both as null here. You see that? Here, my magic class was file output stream and I declared it as null. And in here, my magic class was file input stream and I declared it as null. This code is identical to the previous code, except for the 2 magic lines, or the 2 magic classes. And as it was on the slide, so it works here. And the same thing, I have 2 catch blocks. So I've already explained that we have a file not found and we can have an IO exception. And the same thing with the finally, I put that in a catch block. So now that we've seen this class, we need to compile it. Something else I also want to mention, all my methods are static. You see, the read file method is static, the write file method is static, and the append file method is static. Now, why did I make them static? You'll find many times in Java libraries, we don't want you to instantiate the library to be able to use it. There are exceptions to the rule, and here is where we instantiate a library, because in that case we need to pass it something, the file name. But in our library, we don't need to instantiate the file utilities class. You will see that later. Now that I've created this library, I'm going to give you one more library, the CSV library. Now, the CSV library will allow you to write to CSV files, which you can then open with Excel. Microsoft Excel opens CSV files as spreadsheets. So with this, now we will not only be able to write plain text files, but we will also be able to write spreadsheets. And this is very useful in the practical projects. From this lesson going forward, we will be using these libraries. So you might as well create these libraries or take them out of the repository. But I recommend that you do this code with me so that you can compile it and get it working and learn how to do that. We're going to have a class named CSV utilities. The file name is csvutilities.java. So pause this video, and if you did that, you now have this file. And now let me explain what we are doing here. I have 2 methods, write CSV file and append CSV file. Notice that I am calling the file utilities class. So I'm lazy, I've got no code in here. The file utilities class write file method and the file utilities class append method are used to do the weightlifting. So this clause does nothing. It just calls that clause. It says, hey, yeah, write this. However, when I want to write a spreadsheet, the first line that I write is what they call the header. In other words, this contains the column names of the spreadsheet. And the second line onwards, that is the lines in my spreadsheet that contains the data. So I am passing to this write CSV file, I'm passing it the file name, I'm passing it the header, which we said will be all the spreadsheet column names, but they are just the names separated by commas. And then I'm passing it a line of data, and that will also be values separated by commas. So you can see there is one restriction. You cannot have a comma inside your message, because that will break the CSV file. But under 99.99% of the time, this should be good enough, and for what we want to use it for, it should be fine. Now you'll notice the append CSV file as well as the write CSV file, they both have a body, that is the rows of data. This one does not have the header. You see, only this one has the header. So the first time we write the file, we write the column names. Thereafter, we only write the data, and that we do through the body variable. We're going to compile this class, but before we do that, in Java you will learn when you create code, you need to also write a unit test. You need to use a test to prove that your code works. So I am going to do that right now. I have a file called fileio.java. The class name is fileio. Pause the video and copy up to line 35. Now, pause the video and copy the rest. I assume that you're going to do the exercise with me and you're not going to cheat and pull it from the repository or from the attached files. Let's go now and compile these. What I want to show you here, just before we do that, in my unit test, I have a main method. And in there, I'm going to call the file utilities, and I'm going to do a write file, an append file, and even a read file. So I'm going to write a file, I'm going to append to it, and then I'm going to read it. And then I'm going to do a second test further down, where I'm going to call the CSV utilities class. And here I'm going to do the write CSV file and the append CSV file. So basically this fileio Java class is going to be testing all my code. Now let's go and compile and run this. So we'll start with the file utilities, javvac. File utilities.java, enter. Good, this file compiled. Now there's no main method in a library file, so you shouldn't actually put a unit test in your library file. Create a separate test for that. So that compiled. Now we want to do the CSV utilities. So javvac cs.java, enter. And there were no errors in that library. Now we want to do the file IO, in other words, our unit tests. And that compiled. Now let's run it, and then we will look at the code. Doesn't look like much, but let's have a look at the code. So here we declared a variable called file name. Notice I only used file name for testing the file utilities. I then used the CSV file name to test the CSV file. I did that deliberately because this file name is going to have hello-world.txt and this one is going to have addressbook.csv file. We are now building the building blocks to make our practical project. That was the first thing that we did. Secondly, I had a text here called hello world, and notice that I wrote to the file with the right file, file utilities, right file, and I passed it hello world. Then I did file utilities, append file. I also gave it the file name, and here now in front of the text I inserted a magic character, \n. When you're writing a file and you use \n, it will insert the carriage return line feed. In other words, it'll move you to the bottom of the next line and to the left. So we are now going to get hello world with an exclamation mark written to the file and immediately underneath it again. And then here I did a file utilities read file and I gave it the file name and I stored that in message. And then here I wrote read file file name and the message. Here I wrote append file file name and here I wrote file file name. So let's look at it. Wrote file file name, append file, appended file, and there's the file name, and then read file with the file name, and the text had 2 hello worlds. So it passed this test. Let's now look at the next test. So we created this file name CSV. So here we said wrote file CSV, we did that. And then here we said appended file CSV. But we didn't display that. So let's have a look. I'm in a Linux terminal, so ls minus LA ADDR dot C. Now address book star. See what we get. Aha. So there it is. There's the address book CSV file. And in Linux, I can use the cat command. So cat. And here it did that. It put the column names on name, phone, and mobile. There's a Joe Soap and a Jane Doe. Let's have a look at the code. Here we created the header, and that had the name, the phone, and the mobile. There it is there. And then here, in the body, we put Joe Soap. So that was the first line that wrote. Then here, in the body, I reused this variable body, and I assigned it a new value, and I gave it Jane Doe and her details. And when I called the append CSV file, and I wrote, you see, it came up with the Jane Doe information. Now let's go and open that file. Can you see that my Microsoft Windows has recognized this file as an Excel file? You see it's put an X there. So if I go now and I open it, it opened in Excel. Just space these out neatly. And there you have it. There's my spreadsheet. Let's continue the lesson. The Pojo is an interesting class. Many times in Java, we need to create a class that represents values of an item like an address book or a person. It can be an account. This always has private class variables which cannot be accessed outside the class, but they can be accessed only using getters and setter methods. In other words, indirect access, not direct access. Sometimes we can add special methods to the Pojos to manipulate the variables. In this case, the class variables, and we also call the class variables in a pojo, we call them fields. And we can also use special methods to return the values inside a class. In the pojo, we can create special methods to do that. So let's have a look at the next slide. I created the address book project. You will notice that so far we have written a CSV file that was an address book. But now here I want to have the pojo that represents the data. I have a limitation on the slide, so I'm only able to show 2 fields, name and email address. But in the real pojo that we're going to work with, we're going to have about 6 or 10 field names. That's up to you. You're welcome to add more if you want to make your address book customized for your own use. As we said, the method to retrieve the data is a get name. We have a field called name and we have a field called email. But since we made our field variables private, we can't access them outside the class. We've mentioned that. In the pojo, we use what we call getter methods and setter methods. So the getter methods, here's a getter method that will return us the name, and it's called getName. And here's a getter method that will return us the email, and it's called getEmail. And like we have getter methods, we have setter methods. So this setter method is called setName, and here we have setEmail. And with these methods, we can pass it a name and we can update these values here externally. What you will notice is that the getter and the setter methods, the names of these methods is very specific. Do not change them. We use 2 words or more words. The first word is get or set, and the second word is the variable name, or the name of the variable. Here it's an email, but sometimes you may have more than one word in the variable name. So therefore here you will have more than one word, and these words start with uppercase. Remember, we said when we declare variables, we want to give them long names of multiple words, and always the first letter of the first word is lowercase, and thereafter all the other words are uppercase. They start with the uppercase first letter. And it's the same with methods. Methods have the same naming convention. The first letter is always lowercase, and every other word, the first letter is uppercase. So you're going to have a get name, get email address. Now, here's the problem. If I pass it a name and I want to set the name, I can't go here and say name equals name. That won't work. So Java gives us a special reserved word, this. And if I say this dot, with this I can access all the methods and all the variables. So if I say this dot variable name, and in that case this one here, this dot name, I'm now able to access this variable here, and if I say equals this variable name, I'm now able to take the value I pass in here and store it in there using the this reserved word. I may even use, if I have a special method inside there, I may even say this dot and the method name, although that would be superfluous because inside here I could call the method names directly. But Java does give us that access with the this reserved word. I mentioned earlier that we can create special methods in the pojo. When we were testing the CSV file, you may remember that I had a variable called header and I had a variable called body. And this is the code that goes in my Pojo. And with this make header, what I am doing now is I'm just passing it the names, not the values. So they are inside quotations, you see, double quotes. And that's how I create the make header. The make body is identical. The only difference is that I dropped these double quotes. So now I will declare a variable called body, and I will say body plus equals name, body plus equals email. And you will notice that I'm using a quote, comma, quote. So I'm separating these values with a comma. That's what we call comma separated values, and that is what the CSV file is. And the CSV file is in Java, it's recognized as a way that we can write spreadsheets, and Windows will open the file and recognize that as an Excel spreadsheet. Let's go and look at this in code. Now, for those who want to do the exercise and don't want to cheat, using the sources provided, pause the video, copy up to line 30. Up to line 30. You create a class addressBookPojo and the file name addressBookPojo.java. Pause the video now. Now continue and go up to line 63. Pause the video now. And I'm going to give you an exercise to do. I'm only going to show you the first four getters and setters. So I'm not going to show you the rest, but I'm going to bring the code to the top so that you can see all the field names. As an exercise, write the getters and setters for the ones that you haven't got. In other words, the last four. Pause the video now. And if you want to cheat, you can look at the source code, but I don't recommend you do that. Right. Now let's look at the rest of the code just to see if you got those. So from line 63 up to line 93. Pause the video now and make changes. Okay, now add the last closing bracket right at the side. What you will also notice, the address book Pojo, this is a representation of data. So we use Pojos for things like a customer, an account, or a customer account, a bank transaction. There we use Pojos. Now, in banking, we do not expose certain setter methods. In fact, if you're doing bank transactions, we only provide getter methods. We do not provide setter methods, and we create a special constructor that takes all the fields. So when I created the bank transaction object and I instantiated it, I preset my transaction Pojo with all the values, and this cannot be changed. So it's called immutable. Now, we want to do that because if a hacker breaks into the system, there are no set of variables that he can change the customer name and the customer's account number. In other words, that he can't move the transactions to put money into his bank account. Now let's go and compile this class. And that's all we can do. We can't run this class because, like a library that doesn't have a main method, same with the Pojo. The Pojo should not have a main method. It represents data, it's not functionality or behavior. We'll talk about behavior in the future lessons. We are now going to build our project. It's the address book project. This project will allow us to capture our friends and all the information we want for our contacts, and it will save it as a CSV file that we can open it in Microsoft Excel or OpenOffice. I am going to be talking about design patterns, and you'll be hearing me mentioning design patterns. Now, design patterns prevent us from reinventing the wheel every time. So, in the industry, there are certain standard ways of doing things. So, if we want to write code with a similar behavior to that, then why reinvent the wheel? Use what somebody else has done and call it your code. Now, my design pattern is going to enable me to create multiple different projects. I'm going to have an address book project, and the first class is going to be called address book. Then I'm going to create a helper class, and the helper class is going to be called address book helper. And then I'm going to create a capture class. This is where we get the keyboard input. And then that's going to be called address book capture. And then I'm going to create a Pojo. We've just done that now, and that was the address book Pojo. And I'm going to reuse these libraries, the CSV utility library and the file utility library. Because I'm lazy, I don't want to reinvent the wheel. And after I've built this project, my next project is going to have code so similar, you'll swear I copied and renamed files. That's when code starts looking like that, then you know somebody's working with a design pattern. So later on, I'm going to create another project where we are going to track football or rugby or whatever we want to call it. I'm going to call mine Rugby League, but you're welcome to rename it to Gridiron League or Baseball League. It doesn't matter. So let's say we called it Baseball League. So then the primary class will be called Baseball League, then Baseball League Helper, Baseball League Capture, Baseball League Pojo, and these two classes remain the same. The theoretical part of this lesson has ended, and now we're going to use the code we have, and we're going to build this project. Thank you.